All right, this is worksheet 3, number 3. Let R be the region in the first quadrant, bounded by the y-axis. I don't know that it needed to say that because the first quadrant would automatically include the y-axis. Y equals 2 and 2 cube root of x. There's y equals 2. Let's see, cube root of x looks like that. So if I stretch it by 2, let's see, if I plug in 1, I would get 2. Or I could just go to the calculator and let the calculator graph it for me. Y equals 2. Y equals 2 times x to the 1/3. Again, I think there's a cube root button somewhere in the calculator, but rather than memorize it or try to go find it, I'll just use x to the 1/3. Math 4, thank you. All right, there's 2 cube root x. I'm looking at way more than I need to see, so I'll go -1 to 3 on the x's and then -1 to 3 on the y's. That'll give me a little bit of overlap. I don't like it when my intersections are like right at the edge, because then I can't really see what's going on. Okay, so that was a minute and a half to just figure out what this thing looks like. What is the volume of the solid formed when revolving R about the y-axis? Y-axis. There's my y-axis. So I'm revolving it this way. Is this a dy or a dx problem? dy. So I'm already thinking I got to go 0 to 2 then. Disk or washers? Disk. Good. I'm glad this was a disk problem. We hadn't seen a disk problem in a while. There's no space between the axis and the region. Like, the region is resting on the axis of rotation. So this is a disk problem. So pi r squared dy. So there's only a big R. I don't have to worry about a little r. And that means if you had tried to do a washer, maybe you'd figure it out that's a disk, because there is no little r to be found there. There's big R. So right minus left. Right is this curve, which is 2 cube root of x. But what don't I like about that, or what do I need to adjust on that? I need to turn it into a y. So let's divide by 2, and then cube both sides. So y over 2 cubed is r. Y over 2 cubed. Left is 0, so that doesn't really do anything for me. Okay, so 0 to 2. Pi times r is y over 2 cubed, but then we have to square that. Cube squared would be to the 6th, but you're going to the calculator, so let the calculator worry about the algebra. Math 9, 0 to 2, parentheses. I'm sticking with y's for those that like that. Y over 2 to the, I'm just going to do to the 6th. I'm going to do the math on my own here. It's multiple choice, so if I don't get it right, I can go back and figure out what went wrong. 0.898. Answer choice B. Ian.
Why is there no little r?
Somebody want to answer that? It's a good question. Why is there no little r?
It's a disk.
It's a disk, not a washer? There is no, I mean, where would your little r be? Like, it would always be 0, because there is no inside radius. Which means, not really advised, but you could set up every problem as a washer problem, and you would just have r equals 0 for your disk problems. I kept talking, but I made like a mental note. This problem took 4.5 minutes. On the calculator test, you have an average of 3 minutes per problem. So that one went a little long, but I was slowing way down, talking through things, explaining things. Also, I think that's on the longer side. There will be some that hopefully take shorter than that. But again, I don't have it up there yet. You get 3 minutes of problem for calculator questions, and I think it's 2 minutes of problem for no calculator questions. So they've built in, they know that it takes a little while to hit all the buttons, the math 9, where's the pi button, where do I find the cube root button? Like, they built in time for you to struggle through those things. And so I guess we went over on that one, but hopefully we make it up elsewhere. Okay, that was a good question because it was a dy problem, and those are always a little bit weirder. It was a disk problem, which is, I think, easier than washer problems, but we've been doing a whole bunch of washer problems, so it was good to go back and look at a disk question.